So we can move to the next question.
Yeah, okay. The solids which have the negative temperature coefficient of resistance are, okay. So here we have 4 options: metals, insulators, semiconductors only, insulators and semiconductors. Okay.
So negative temperature coefficient means as the temperature increases,
then
resistivity decreases. If it is those slight decrease also, it will be negative temperature coefficient.
Yes. So semiconductors has more value for negative temperature coefficient.
And insulators also have
small value, but it's also negative value. So we can choose the option 4th one.
Both insulators and semiconductors have the negative
we can log
temperature
the option
4 we can go.
Yeah. Okay.
Okay, sir.
Okay. Next question. Light of frequency 1.5 times the threshold frequency is incident on a photosensitive material. So here the frequency of light is 1 times the threshold frequency.
Yep.
Okay. So in this case, photoelectric emission occurs. Okay.
Because again, above the threshold frequency, the sufficient frequency
emission occurs. Okay, fine. What will be the photoelectric current if the frequency is halved? Frequency is halved, then it becomes 0.75 times threshold frequency.
That's only.
So there is no photoelectric
That's
emission.
below the threshold frequency.
Yeah. But they increase the intensity.
Yeah.
Students may confused.
Of course.
But intensity does not depends on the photoelectric emission. I think frequency
to take place. Yeah. Frequency.
So does not occurs any photoelectric emission. So there is no current.
Actually, some of the students had the confusion that photoelectric current. Current, if you consider, that depends upon the intensity directly. But here the process itself doesn't take place. Because
emission does not take place.
Because it's less than
threshold frequency.
That's you have to consider.
Simple question.
Yep,
very simple. If the students know the concept very well,
so
then
no
they can write the answers.
So we can log the answer.
4th one.
4th one. 0 will be the answer for that.
So we can move to the next question, 60th question.
60th question.
Okay.
That's from AC, alternating current. Again, one more question from alternating current coming. A series LCR circuit is connected to an AC voltage source. When L is removed, the inductor is removed from the circuit, the phase difference between current and voltage is pi by 3. So if L is removed, then CR circuit it is.
CR circuit.
If instead C is removed from the circuit, the phase difference is again pi by 3. Then LR circuit also phase difference is pi by 3.
Here it is phi is pi by 3. Phase difference is pi by 3.
So
it is also phi is equal to pi by 3. So directly we can understand that it's a resonance condition.
Of course, X is equal to XL will be there.
Means such type of condition. Not resonance occurs, but such type of condition. Yes. So here we can write the tan phi. Tan phi is equal to
XC minus XL by R.
XL. So here only XC is there. XC divided by
R will be.
Okay, here it is tan phi is equal to
XL by R.
XL by R. Okay, so here phi is pi by 3 in both cases. So tan phi is same. So XC by R is equal to XL by R. So X is equal to XL.
So we could say that
XC is equal to XL. So in the LCR circuit, XC is equal to XL.
That means resonance
conditions.
And resonance, the least impedance is there.
Yes.
And
maximum current. And current and voltage are in phase. So there is no phase difference. So phi is equal to 0. Phi becomes 0 in that LCR circuit. Then cos phi becomes 1. So power factor is cos phi. So
that is 1.
Cos 0 is 1.
And that is positive 1.
Simple.
So there is answer. That question.
Okay.
So we can move to the
next question. A spherical conductor of radius 10 cm has a charge of 3.2 into 10 raised to minus 7 coulomb distributed uniformly. So we have a spherical conductor of radius
10 cm.
10 cm. So spherical conductor. Okay. Radius is 10 cm. Now, what they asked? Okay. There has some charge of Q
equal to
3.2 into 10 raised to minus 7 coulomb.
And they are distributed uniformly throughout the surface.
Yes. What is the magnitude of electric field at a point 15 cm from the center of the sphere? So you want to find the intensity of electric field 15 cm from the center of the sphere. So it's a direct question, I think. So you want to find intensity at this point. So expression is E is equal to 1 by 4 pi epsilon. So 9 into 10 raised to 9 into Q by R square. So 3.2 into 10 raised to minus 7 divided by R square is I think 15.
No, 15 centimeter is there. It should convert to meters.
So 15 square into 10 raised to minus 4.
So it's a concept like this only. If you consider the point outside the sphere, then sphere will be acted as a point charge.
Point charge at the place at the center of the sphere. So by solving this 9 10 raised to 9 into 3.2 into 10
10
raised to
7.
minus 7 divided by 15 square, that is 15 into 15. So it's cut. This is 3
Yeah.
and this is 5
Yeah.
and it's cut
5.
5. So answer is 3.2
And that
into
10 minus
10
4
raised
also will
to,
be there, sir.
this will be 10 raised
10
to,
minus 4 you take it up.
okay,
So 10 plus 4 will come in the numerator.
yes, so 10 raised to plus,
Plus
4.
4 will come there. Yeah.
That is plus 4, 13.
13.
13 minus 7 is
6.
plus 6. Okay,
Yeah.
divided by 25.
Yeah.
So 3.2 divided by
25.
25, 10 raised to plus 6.
So 32 into 10 is 5.
32 divided by 25.
25.
So
So almost to
that is
1.28.
10 raised to 5.
Yeah.
Okay, so answer will be 1 point something, 10
Yeah.
raised to
So
5.
here all the options are 1.28.
1.28 is
So
so.
the
So
power you have to
we
consider.
we don't want to solve this.
Yeah.
Okay.
Yeah, the power you have to confirm it.
Yeah.
So 10 is to
1 point
1.28
something,
into
10 raised to
5.
5.
Into the column.
Yeah.
So we can log the answer 2.
2.
So 2 will be the answer.
Exactly. Okay. One next
Okay.
question.
So we can move to next question.
Okay. See, the previous question is from first chapter of
Yeah,
first-
aerostatics. Plus one.
Aerostatics.
No, 12 chapters.
Yeah.
Now question number 62 we are moving to. So again from grade 11th. This question
System
is in
of
the order
particles.
of the code E2 actually we are solving.
E2,
The
E2.
order in the question.
Yeah, yeah.
Question number 62.
I think this question is from a system. We can consider a system of particles.
Yeah, of course, system of particles and rotation motion.
But I think there is no question from motion in a plane.
Yeah, no.
So
for
it
now.
may be taken into that chapter also.
Or
Cross
can be.
product.
Yeah, vector
Okay.
product can be.
Vector product.
considered as.
Okay.
Find the torque about the origin when a force of 3J Newton acts on a particle whose position vector is 2k meters. So we have the force and position vector of the particle is given. And you have to find the torque. The basic equation only, torque, tau is equal
R
to
cross F.
Yeah, R cross F is there. So vector R cross vector F is there.
So its expansion will be mod R mod F sin theta into n cap
N
unit
cap.
vector.
So,
So that is equal to mod R is
3. So 2
2
into 3.
3
That's a mod R.
yes
Okay?
into sin 90 is
90.
the angle between
Because J and K will be sin 90. That's 1.
1.
Okay.
In-
And there will be N cap will be there. So
N
N cap will be
J cross sorry
K
K cross J.
Yeah. K cross J is coming.
Yeah.
So there you have to take care actually. Because here J cross K is I, and K cross J is negative I.
Negative I.
So negative X will be there.
Yes.
So this will be negative 1 will be there. So this will be negative 6 into 1 is 6
I
only.
cap, I cap.
That means Newton meter will be the answer.
Yeah.
That is the torque.
So option
So negative 6 I.
3.
Newton.
All the answers are 6 I think.
Yeah, all are 6
So,
only.
we
So
should take this
positive I is there, negative I is there.
Yeah.
J and K is also coming there. So negative is very important. That is crucial point only. So we can log the answer 3 is the answer for
simple
that.
question.
We can move to the next question, sir.
Sure.
Question number 63.
Yeah. A charged particle having drift velocity of 7.5 into 10 raised to minus 4 meter per second. So VD, we know
Drift velocity is
VD.
VD.
That is 7.5 into 10 raised to minus 4 I think.
Yeah.
Now, in an electric field,
Electric field is given 3 into 10 raised to minus 10 volt per meter.
Okay. Has
Has
a mobility.
You have to find the mobility actually. That equation only.
Oh, VD
One
by
degree, yeah, just that
mu
question only.
is equal to
VD by
VD
E
by mod E.
E.
Okay.
Yeah, mod E.
That is equal
The
to
value of E only.
yeah.
So that will be 7.5
7.5 into 10
10
raised to minus 4 divided by 3 into 10 raised to minus 10.
Yeah.
To solve it. So it's written as 75 by 3.
Yep.
75 by
Divide
3
3
into 10 raised to this will be 10 raised to minus
5.
5.
Yeah.
So
Plus
plus
10,
10 minus
so
5, 10
into
raised to
5.
plus 5.
5.
That is 25.
Yeah.
25 into 10 raised to 5.
5. So here we have 2.5 into 10 to the 6 is there, sir. So you can write that 2.5 into 10
Yeah,
to the 6.
2.5 10
Into
raised
10
to
to
6
6 will
can
be.
be written as.
So the answer 2 we can log I think.
Okay, sure.
Is it?
Answer
So,
is
2
2.5 and ratio plus 6.
plus 6 we can
Yeah,
have.
2
That's the value of the mobility. So mobility of the direct ratio we have ratio of drift velocity to the magnitude of electric field.
Electric field.
That's the meaning of the mobility. We can move to the next question, sir.
Okay,
so
next-
this
next.
63 is from current electricity chapter.
Yeah.
Okay. And 64th question, that's from our
Ray optics.
ray optics chapter. A ray is incident at an angle of incidence I on one surface of a small angled prism. So it's a small angled prism.
Small angle.
Special case.
Okay.
With angle of prism A and emerges normally from the opposite surface. So if a ray emerges normally from a surface, then angle of emergence will be
0.
0, sir. Because it's passing along the normal.
Okay.
Then if the refractive index of the material of the prism is mu, then the angle of incidence is nearly equal to. So angle of incidence we have to find out.
We want to
small
find
angles.
I in terms of, I think, A and mu.
Yeah.
Angle of prism and refractive index of this prism.
Yep.
Yeah. So we can use Snell's law at this
Yeah, that one.
range. So that is sin I by
Sin R.
sin R1 is equal to refractive index of
Mu.
this
Yeah.
prism.
Prism.
Okay, and this is a small angle prism, so sin A approximately equal to I.
I only.
And
Yeah.
sin R1 is also
R1.
R1. So from here, I by R1 is equal to mu.
Mu. We can write it.
Okay.
Yeah.
So another one, we have the equation
For refractive index, we have the direct equation.
Yeah.
Yeah.
For delta, the angle of deviation. Delta is equal to A into n minus 1
Yeah.
for small angle equation.
One equation. And also
Another
delta is equal
equation,
to. Yeah.
delta is equal to I plus E minus A.
Yeah.
That's the equation.
Two
So
equation.
here, angle of emergence is 0.
0. That's because saying the opposite is going perpendicular. Imagine perpendicular.
Yeah.
So it's passing around the
Perpendicular
normal.
to the surface.
Yeah.
And parallel to the normal.
Normal.
Okay. So angle of emergence is taken as 0.
0.
So from here, delta is equal to I minus A.
Yeah.
So we can equate these two relations.
Yep.
So here n is taken as refractive index,
Yeah.
but here it is given mu.
Mu, of course.
Okay.
Yeah,
So we can write in terms of mu. So A into mu minus 1, that is delta, is equal to I minus A. A taken into LHS.
Yeah.
So A into mu minus 1 plus A is equal to I. So A can be taken out. So mu minus 1 plus 1 is equal to I. That is, this is 0. So A mu is equal to I. So
I.
angle of incidence is A mu.
A mu.
Simple question.
Very simple question. So
The-
just 1 degree up you have to check it.
Yeah.
Two equations you have to compare them.
Compare.
From the prism questions
Simple.
actually. Reference of small angle to prism, this concept actually. Okay. So you have to take care actually this angle of emergence is 0 here.
Yeah.
Otherwise you have
That
to
should
compare
be
this
taken.
one. Yeah.
Move on to the next question.
So question number 65 is from thermal properties of matter,
Yeah.
the chapter. The quantities of heat required to raise the temperature of two solid copper spheres of radii R1 and R2. So we have two spheres here.
Yeah.
So solid copper spheres.
Copper spheres.
R1 and R2 is there. The relation between R1 and R2 is R1 is 1.5 times R2.
Yeah.
So R2 is smaller, second one is smaller.
Smaller.
Another is
First one
1.5
is
times.
bigger. Okay.
You have to raise through 1 Kelvin.
So we want
These are in the ratio.
we want to find the
Ratio
ratio
of
of
heat.
heat required.
So Q1
for
by Q2.
Q1 by Q2.
Yeah.
So here Q1 is equal to mass of this body.
Yep.
We can take
M1.
as M1.
Yep.
And specific capacity taken
Both
as
of us,
S,
yeah, both are same. Solid capacitors are.
Yeah.
Spheres are there.
S taken as specific capacity.
Yeah.
Into delta T.
Yeah.
Change in temperature.
So,
Okay, both are same material, I think.
same
So-
material and the same temperature
Same.
difference.
So S and delta
is
T are
common.
same. So here Q2 will be equal to M2 into S delta T.
Again.
We want the ratio of Q1 and Q2.
Yeah.
So it's simple. Q1 by
Q2.
Q1 by Q2 is equal to S and delta T.
Cancels.
Cancel
So
out.
M1 by M2.
So M1 by M2. M1 by M2. So that is equal to mass can be written as
Density
terms of
to
density
volume.
and volume.
Yep.
Yeah. So density are
Again,
same.
it is same here, here.
So density into 4 by 3 pi r cube.
Yep.
Pi into
R1
radius
cube.
of. So 1.5.
So 1.5
1.5
into
is
R2
3
cube.
by 2.
Yeah.
3 by 2
R2 cube.
R2
The whole cube.
cube divided by rho into 4 by 3 pi into R2 cube. So strike off. Answer is R2 cube and R2 cube cancel out.
So 3 by 2 whole
Answer
cube.
3 is, oh yes, 9 by 4 is the right answer. Sorry, 9
And 3 cube, 27.
Cube,
Yeah.
27.
27 by 8.
27
By
divided by 8 is the right answer. So 3 cube by 2 cube.
So here we use the concept that we got the concept that ratio of heat will be equal to ratio of the masses.
Masses.
M1 and M2.
If what do you say?
Same specific capacity and
Capacity,
same temperature differences.
Differences.
So we substituted volume into density is mass.
Yeah.
So we got similar terms here, R2 in terms of R2 also. So it's very easy to calculate.
Yeah, very
so we can log the answer. Will be
Answer.
27 by 8. 1 is the answer.
1 is
Yes.
right answer. Yeah.
Because about 65.
Okay.
We can move to the next.
This question is also from thermal properties.
Thermal properties of matter. So this time thermal In compared to mechanics, thermodynamics have some more weightage.
Thermal have more
There
weightage.
it is.
Next question. When a uranium isotope 92-235 is bombarded with a neutron, it generates krypton and 3
3689,
neutron.
yeah.
And it's a direct
Second-
question.
Yeah,
From nuclei, direct
yeah,
question.
used to do.
So barium, krypton, barium
Used
are
to
produced.
have it directly as a-
directly.
Yeah.
Otherwise,
Used
we
to
can calculate like this also. While bombarding a neutron with the uranium, then it is split into
Equation should be balanced.
balanced. Yes.
So 3 neutrons are there.
Yeah.
And a krypton is given there also.
Also.
Krypton 89 is there. So 89 plus 3,
Yeah.
92.
92 plus
144 will be 235.
No,
So only one option
sorry,
is there.
here one
235
neutron
is
also
there.
extra.
Yeah.
So that 1 plus 235, 236.
From
And
there
balanced,
you have
yes.
yeah.
The 3
And only one
neutrons,
option is there 144.
144 plus 3 extra neutrons
Yeah.
plus 89 should be 236.
That's correct only.
Yes. Right question.
Then atomic number also you can concern if you
Yeah,
want.
yes.
So there will be 36 there and here 92.
Yeah.
So 56.
36 plus 56 is 92. Neutron
That
plus-
question 6
yeah.
actually it is. So we can log the answer.
It's very
one
simple
actually.
question, I think.
Yeah. So it's from grade 12th syllabus, nuclei chapter.
Nuclei.
Yeah. You can move to the next question, 67. So.
67.
The phase difference between displacement and acceleration of a particle in a simple harmonic motion is from oscillation chapter from grade 11th.
This very,
Oscillation.
very simple, I think.
That question is like
basic,
actually.
basic level. So it's
Once we studied the simple harmonic motion, we formed the graphical representation.
Yes.
That's of the phase difference we discussed.
pi.
Yeah, pi.
Directly we can write the answer as pi.
Because displacement is y equal to a sine omega t and acceleration a is equal to minus a omega square sine omega t.
yeah.
So
It is
here
minus negative sign.
Just that because of negative. One is positive maximum, then other will be negative maximum.
Negative maximum. So there is a
It should be
pi phase
pi
difference.
phase difference
between y
that
and
question only it is. So question answer 1 we can log it.
1.
for that.
1, 1, 1.
Will be 1 for it. Okay. So that's also from grade 11th chapter, oscillation chapter.
Oscillations.
Now question number 68, sir. We can
Yeah.
move it.
A resistance wire connected in the left gap of meter bridge. Okay. I think it's from current electricity.
Yeah, consider it again.
Balances a 10 ohm resistance in the right gap at a point which divides the bridge within the ratio 3:2. If the length of the resistance wire is 1.5 meter, then the length of 1 ohm of the resistance wire is. It's very simple. I
It's
think.
comparison only.
Comparison only.
Yeah.
So we can write this is the resistance wire,
Yeah.
left gap,
Yeah.
and right gap there is a resistor.
Yeah.
Okay, and is balanced among a wire.
Yeah.
Okay, so here left gap a resistance wire is connected in the left gap. So this is R, taken as R.
The other one is
Other one
X.
is 10 ohm.
10 ohm.
10 ohm. So this ratio
Is
should
given-
be equal to the length ratio also.
Yep, sure.
So from here R by 10 is equal to length divided the ratio 3:2.
3:2,
So that is
yeah.
3 by 2. 3 by 2. From here R is equal to 33 by 2.
That's
that is
15.
15.
Ohm.
So 15 ohm is
Is
the
the
resistance of this resistance wire.
That is in left gap.
So the length of this resistance wire is given 1.5 meter.
Yeah.
So the question is that what should be the resistance of that resistance wire having
1 ohm.
1 meter?
So total is
we-
15 ohm.
Yes,
length is
1.5
1.5
meter
Has
having
15 ohm.
15 ohms. So from here 1 meter will have 15 ohm by 1.5. So
You have to
answer
get
is-
1 ohm, how much you will have actually?
Sorry.
1 ohm we have to get it.
Oh, sorry. How much length?
Yeah.
For one.
So
okay,
1.5 divided by 15.
Okay, fine,
Yeah.
fine. So we can write it as 15 ohm
Has
as
1.5 meter. length.
1.5 meter.
So
From
1
here,
ohm how
1
much
ohm,
length will be?
1.5
Divided
by
by
15
15.
meter.
So
That is
that will be-
0.1.
Yeah, 0.1. That is 10 to the minus 1.
meter.
Yeah.
Having 1 ohm
Yeah.
resistance.
So 1 into 10 to the minus 1 meters.
1 into 10 raised to minus 1
Yeah,
meters.
that's actually answer 2 we can log it.
2 is the
That's answer.
2 is the right.
That's from chapter current electricity. Actually, this time the 5 questions came from current electricity chapter.
Oh, yes.
5 questions.
Yes.
I think that is the most has weightage of all the chapters together. If you
Yeah.
take it. Total weight. And there are also very direct questions only.
That was so.
Very few,
All
just
the
1
questions
degree
are-
only
yes.
we given.
I think this question is some more.
Little bit as well.
Yeah.
Remaining was direct graphical question we got it.
Yeah.
Drift velocity question, mobility
yes,
questions.
yes.
So were direct questions.
Direct question.
We can move to the next, sir.
Yes. Next
69th
is from
question.
fluids, mechanical properties of fluids.
Yeah. A capillary tube of radius r is immersed in water and water rises into a height h. So we have in a beaker, okay, water is there we have a capillary tube we inserted.
Yeah.
Okay. So to this height, it adds.
Okay.
Okay. So that is H is given here.
Radius of tube
R.
is R.
Now, the mass of the water in the capillary is 5 grams. So here the mass is also given 5 grams. Okay. Another capillary tube of radius 2r immersed in the water.
Okay.
So the same water, another have the radius 2r is immersed.
Yeah.
Then the mass of water will rise in the tube will be. So that mass of that amount of water we have to find out.
We want to find.
Okay.
Yeah. So it's simple question, I think.
The ascent formula we have to use it.
Yeah.
H is equal to
H is equal to H
2
is
S
equal to
cos theta by
2
R
S
rho G.
cos theta by
R rho
G. Okay. So in both of the cases, the liquid taken are the same.
Same.
So density, angle of contact,
This all will be same.
G.
Surface tension will be
all are
same.
same.
Yeah.
Okay.
So we can say H is inversely
H
proportional
is
to
inversely proportional to R.
R.
Okay. When R doubled, H halved.
Halved, of course.
So here H will be the height.
We can say H by 2. Yeah.
Okay.
Yeah.
So here we can calculate the mass in terms of density and
We have to
volume.
count the mass actually there.
So raw density into volume.
Yeah, density into volume
Pi r-
will be equal to
yeah.
mass we have.
Mass. So that is equal to density into density pi r square.
H.
Pi r square H.
Because
That
it's a
is
cylindrical
5
shape
gram.
actually.
Cylindrical
Volume
shape.
of the cylindrical shape, you know.
Area into height.
Area into height. Pi r square and H will be
H.
there. That's given
While-
5 gram here.
While
That is M actually.
yeah,
Now M dash also we can write, sir.
here yeah,
M dash will be there.
raw is the same.
Rho same there into pi into
R is 2R.
2R. So 2R square
Into H by
into H by 2 will be there.
Yeah.
How
That
is
is-
getting H by 2 means we found that as the radius doubled,
Doubled.
H half.
Halved.
If all the other criteria are same.
Same. So raw into pi into 4 r square H by 2.
So 2 cancels 2R
And
square
so
is
this, yes.
Ah.
And raw pi r square H.
That is a
raw
5
pi
actually.
r square, which is
This
5.
is 5.
5. So 2 into 5.
Five.
So it is
That
10
is
gram.
10 gram.
10 gram is the
Answer for M
mass of
dash, the new
liquid.
mass will be.
Yeah.
So the answer will be, third one will be the answer, sir.
10 grams.
Grams. 69th question. So that's from fluid chapter.
Fluids.
The capillary rise and the surface tension topic.
Yeah.
We can do it. Next question we can move.
Okay,
The 70th question.
The ratio of contributions made by the electric field and magnetic field components to the intensity and electromagnetic waves.
So that's from grade 12 syllabus electromagnetic wave
EM
chapter.
waves, I think.
EM waves.
EM
It's a
waves.
very direct question actually.
Direct
EM
question.
waves, you know, we have two components, electric field and magnetic
Magnetic
field. And we know that the energy contributed by both field will be same. Electric and magnetic field.
Yeah.
So,
So it's
intensity
ratio.
also ratio. Nothing to worry. 1:1 will be
It's
it.
direct question, I think.
Direct question, of course.
1:1.
Yeah. So that is this topic also actually, electromagnetic
Yeah.
induction. I mean, sorry, electromagnetic
Electromagnetic
waves. And but see, electromagnetic induction, no question.
No questions
This time. So that's question number 70.
71, I think.
We can move to the next question.
Yeah. Oh, that is from waves.
Yeah, wave optics,
Wave
yeah.
optics. In Young's double slit experiment, if the separation between coherent sources is halved, so the letter we taken, the distance between coherent sources as
Small
t,
d.
small d.
Yeah.
Okay.
That is
D
half.
becomes halved.
Yeah.
Okay. Now,
The distance of the screen from the coherent source is doubled.
Okay,
Then
so-
strange verification we have to use it. sir.
okay, this is halved
Ah.
and capital D.
Is,
Doubled, I think doubled. Yeah,
Yeah.
doubled. Now,
So we
friends,
have the equation
simple.
situated-
Beta is equal lambda d
Beta
by
is
d.
equal to
Lambda
d by small d. But lambda is a wavelength, no change here.
Yeah.
Capital D and small d is changed.
Yeah.
So d dash beta dash we can say lambda into that
2D,
is 2d comes
divided by d by 2.
d by 2. This
Two.
2 goes up into 4. So beta dash will be
4 beta.
times beta.
Beta.
That is will be beta dash.
Simple question, I think. 4 times.
Yes, sir. 4 times.
So we can
So,
log 3.
3.
3 is the answer.
And 3 is the correct answer for this. 4 times beta dash should be.
Oof.
That's from wave optics.
Yeah. I think there is one more question also from wave optics.
Wave optics actually we got actually normally.
From resolving power.
Yeah, resonant power equation is there.
Limit
And
of resolution.
yeah, and the polarizing angle also one question.
Oh,
came
sorry,
actually.
yeah, yes,
Total
yes.
3 questions.
Three
came
questions,
from
three questions,
wave optics,
yes.
We can move to the next question, sir.
Sure.
As from long solenoid of 50 centimeter length having 100 turns carries a current of 2.5 ampere. The magnetic field at the center of the solenoid is It is from the moving charges and magnetism.
Moving charges.
Application of ambient circuit law.
Question, I
Yeah.
think. Yes.
By using ambient circuit law, we found the magnetic field inside the
Intensity of
solenoid.
magnetic field inside mu 0 and
We
I.
have B is equal to
Mu 0.
mu 0 into N into I. Where N is the number density or number of turns per length.
unit length. Yes.
So we can have mu 0 into N by L
into I.
All the terms are given directly
Yeah.
here.
That is equal to.
Yeah. Number of turns is actually
I think
100.
We want to find the exact answer. I think.
Yeah,
in
big.
Tesla.
Yeah,
Okay.
Tesla.
So 4 pi into 10 raised to
Minus
minus 7 into N is 100 divided by its length
50 centimeter, so 0.5.
0.5 taken.
Yeah.
Into I is 2.5.
2.5.
2.5. That is equal to.
Yeah.
2.5 by 5 is 5.
Yeah.
2.5 is 5.
Yeah.
5. So 5 into 4, 20.
20.
20 into 100 to 2000.
Yeah.
2000 pi into 10 raised to
Minus 7 is there.
Answer in terms of pi, no.
So you can say these 3 zeros and minus 7 you can cancel, sir.
Okay,
That's minus
sure,
2
sure.
put
That is
2 pi
2 pi
into 10 is minus
10 raised to minus
4. Yeah. So
Okay.
2 pi is 6.28.
Yeah, 6 point something. 2 into 3.
Yeah.
6
3.14
point something.
reported.
So 6
6.28.
points 10 raised to minus 4 Tesla.
Yeah.
Simple. 1.
First option we can do. Option 1 is correct here.
Yeah.
So as from ambient circuit law application from moving charge and magnetism
Magnetism,
chapter.
yes.
Yeah. We got only one
Shall we
question
move
from
to
that
next
chapter.
question?
Yeah,
Yeah.
of course we can move to the next question.
I think is this magnetism. I think one question.
Yeah, only just first question from moving charges.
Moving charges.
Question number 73. A ball is thrown vertically downward with a velocity of 20 meters per second from the top of a tower. So tower question it is. It hits the ground after some time with a velocity of 80 meters per second. The height of the tower is. It's a direct question from motion in straight line chapter.
Direct questions. Very
Application of
simple.
motion.
Like a board exam level question, I think.
Level question. Not that much hard.
Yes. So we know U, V.
Is
We
given
want to- we want
and
to
G is
find-
given early. We have to find the height.
G
So we can use the third equation, sir.
Yes.
H is equal to
V
V
square minus U square by 2G.
2G.
That is 80 square
Minus 20 square divided by 2 into 10.
20.
Yeah, 20.
Take a 20.
Yeah.
That is equal to 6400
Minus 400
400
divided by
by
20.
20.
Yeah.
6000
By 20. So that is 300.
300.
That simple. So that's actually
Four. We can log the 4.
We can log the fourth. 300 meters is the height of the tower. So it's simple equation of motion. Third equation of motion we have to use it here.
Yeah.
Okay, nothing to worry about it.
Only one question came from this chapter.
Yeah, actually motion is plain no question came.
We
Projectile
can.
and all many topics.
Yeah.
Students used to
Speak
focus
on-
more.
yes.
No question
But
came.
no questions.
Even circular motion also didn't came from the. Okay. We can move to the next question.
Oh,
sir.
sure.
74th is also another direct question.
For which one of the following Bohr model is not valid?
Yeah.
I think Bohr
That's
model
true.
is valid only for
Hydrogen-like atoms.
hydrogen-like atoms. So here hydrogen atom. Okay.
That's
it's
from
valid.
atoms chapter, sir.
Okay. Yeah.
Question
Atoms.
number grade 12th.
And the next one is singly ionized helium atom contains only one electron.
Yeah.
So that is
it's also
also
hydrogen
hydrogen-like
atom. Hydrogen-like atom.
Deuteron atom is also containing one electron.
Yeah.
So
Hydrogen-like atom.
here the option is incomplete.
Fourth only is
The option is incomplete. Can you?
yeah, that's okay. A singly ionized neon atom is actually.
Singly ionized
So it is ionized
neon.
neon atom.
Singly ionized. So
Yeah.
Ne plus.
Yeah.
Ne plus.
So we have an E plus actually, sir.
I think neon, that number of neon is 10.
Yeah. So Ne plus will have
Ne
nine.
plus have 9 electrons.
Yeah.
So it does not.
Not like a hydrogen atom.
Yeah.
So we can have the answer as the fourth one will
Fourth
be
one.
only
It will
the
not-
exceptional option.
Yes.
So elimination method you can use here.
Sure.
Yes. 74th question. Fourth is answer. We can move to the next one, sir.
75th question.
Yeah, 75th question. The average thermal energy for a monoatomic gas is. So Kb is
Direct-
Boltzmann constant, T
direct
absolute
question.
measure. Another direct expression is
Direct
asked actually here.
expression, yes.
That's from kinetic theory, sir.
Yes.
From kinetic theory we got 3 questions actually this time.
Yes.
From kinetic theory 3 we got, and thermodynamics 1 question,
One.
thermodynamics is 2. So total 6 questions from that
Thermal.
Thermodynamics 6. All of you know it, monatomic gas
3 by 2 kb.
kBt. That answer is
So-
this. So second one. Good. You can move to the next, sir. 76th.
Sure. Two particles of mass 5 kg and 10 kg respectively are attached to the two ends of a rigid rod of length 1 meter. So we have
With
a
negligible mass,
rigid
yeah.
rod. Yeah.
Yeah, rigid
Negligible
rod.
mass.
Yeah.
So 1 meter rod and masses are 5
5
kg
kg and 10
5
kg.
kg and 10
10
kg.
kg.
Okay, fine. Now, what
Then
they
find
ask-
the center of mass, sir,
center of mass
of the system.
from 5 kilograms,
kg.
I think. Like,
That's
we
from
want to find
system
the
of
center
particle. Is the second question from that chapter actually.
Yes.
2 questions from
Two
that.
questions.
Yeah.
So we want to find the center of mass. The
That's
location
from
of
five-
center of mass from 5 kilograms.
So 5 at origin.
This taken as origin.
As a 5.
Yeah. So this is the length.
Yeah.
X is CM, center of mass.
Yeah.
So X CM is
Is
equal
equal
to M1
x1
X1 plus M2
the very basic equation you can use
by
m1 x1 plus m2
M1
x2
plus M2. That is equal to, this is X1 value is 0.
Yeah.
So this term becomes 0. 5 into 0. 0 plus, here it is 10, mass 10 into X2. This length is
1
1
meter.
meter. 1 meter.
So,
So,
100
options are in centimeter.
So,
So,
can
we
put
can
100
take as
centimeter.
100 centimeter.
Yeah.
Okay, divided by total mass is 5 plus 10, 15.
15.
15. That is equal to, answer is 2 by 3.
Yeah.
This is 2 and this is 3. So 200
By 3.
by 3 is the right answer. So answer
That's
is
almost
approximately 67 centimeter, I think.
Yeah.
This value centimeter.
200 by 3,
We can
67.
log the answer. It's a direct question,
I
simple.
think it is too hard to lose the mark, I think, sir.
Yes.
Is it?
I think there is a question just like this carbon monoxide.
Yeah, I used
type
to come.
question.
Yeah,
And
similar
then
question.
NCERT,
Yeah,
NCERT.
The very direct, very basic expression for center of mass.
Sure.
Directly to implement. You
Only
get
we
answer
want
here.
to find only one coordinates.
Yeah, that's only. Because so this is from system of particles. That's
Yeah.
the second question from system of particles.
Yes.
We can move to the next.
Next question. Sure.
77
I
question
think it's
number.
from waves.
Yeah. In a guitar, two strings A and B made up of same material are slightly out of tune and produce beats. It's regarding beats. Sir.
Beats.
So beat frequency is given 6 Hz, basically. When tension in B is slightly decreased, the beat frequency increases to 7 Hz. If the frequency of A is 530 Hz, the original frequency of B will be. So we have two strings here.
Yeah.
Okay. So
A
two
and
strings
B.
are there. A is there and
B is
there. Two strings are there.
They are out.
Okay.
They are vibrating with other different frequencies.
Yeah.
So there will be beats.
Beat frequency
There's
is
a
6 Hz.
Slight difference in frequency.
Yeah.
So there
Then only beats will be produced.
Yeah.
So 6 Hz difference is there.
Yes.
And here in B, if it decreases tension,
Yes. Then its frequency also
little bit decrease
decreases.
will be there. So then it becomes 7 Hz the beats frequency.
Okay.
It becomes 7
When
Hz.
when the tension of B decreases,
Yeah.
then the beat frequency increases.
So there one thing can do, the difference may be nu A minus nu B also, nu B minus nu A also.
Yeah.
Both can be.
Gain B.
Yeah. But here saying if B is decreased, then the beat frequency increases
Increase.
actually.
So-
So of course nu A will be greater than nu B.
Greater than B. Yeah.
That logic you have to use here
Yeah,
actually.
Yes.
For nu B, if tension is decreased,
Yes.
then the frequency also
Frequency.
decreases. So of course, the beat frequency increases, then nu A should be greater than nu B.
Nu B.
That logic you should keep there, of course. Nu A
Exactly.
should be greater than
Nu B. Okay.
From that idea.
Then in the second case, when the
It is,
tension of B reduced,
Yeah.
then beat frequency becomes 7
7.
Hz. So we can write nu A minus nu B dash.
Yeah. That
as
becomes 7.
7 Hz.
Yeah.
Okay.
And
From
A is given 530.
yeah. From this expression only we can find the value nu A. I think sorry nu B.
Yeah.
Already
530 is
value
a-
of
that's
value
bigger
of
one.
Nu A is
Here
given.
3 and 4 no chance.
There's
for
no
B.
chance. Yeah,
Because
yeah.
that's greater
Yes,
than
yes,
A.
yes.
That's directly can.
Yes, yes.
So 2 chance 523, 524 is
24
there.
is there.
But original frequency is asking.
Yes.
So 6 is adds.
6 adds.
So 530 minus 6.
6. That is
524.
524.
So
Correct
524
answer.
hertz.
Yes. Exactly.
Just logic concept is
From this relation we can there are two chances are there,
Yeah, there.
for the frequency nu B.
yeah.
What's
536 also
maybe
there, 524 is there.
536
Or 524 is there.
524 is there.
Two chances are
Two
there.
chances. Okay.
But we
the
confirmed
frequency-
it's nu A is greater than nu B.
Good. So answer is 524.
Yeah, that's one. 78 question we can move.
Yeah.
Two cylinders A and B of equal capacity are connected to each other via a stopcock. A contains an ideal gas
Yeah.
at standard temperature and pressure. B is completely evacuated. The entire system is thermally insulated. The stopcock is suddenly opened and the process is. So here we have two cylinders. Sir.
Yeah.
Okay.
A and B.
cylinder A and cylinder B.
B.
Two cylinders we have.
Yeah.
So
Okay.
both are connected with a pipe
Okay.
and blocked with a stopcock.
Okay.
So cylinder A has an ideal gas and cylinder B is
Vacuum.
vacuum.
And the entire system is
Thermally
Insulated.
evacuated. Okay,
Insulated.
thermally insulated.
Insulated.
So thermally insulated means no heat flow,
No
hot
heat
air flow,
flow, yeah.
outside and
So
inside.
its system is this process occurring is adiabatic process.
Yeah.
No doubt at all.
No doubt at all.
Okay.
Okay. And if it is sudden expanded, of course, the gas start to expand to this B
Okay.
against vacuum.
There will be a slight confusion. That means maybe isothermal.
Also.
Okay. And if we consider the initial and the final case, then it will be isothermal process.
Yeah.
Okay.
But it's a sudden expansion happens, sir.
Yes. But in between the process.
Yeah.
In between the process, the temperature slightly varies.
Varies, of
But
course.
if we consider the initial and final
Cases
cases, then there is no change in temperature
at all.
So, but the more correct answer is adiabatic process.
Adiabatic
so
process.
the system is adiabatic in every stages.
Every stages.
Okay, so
that's
we can
most correct.
conclude
Most
the
optimal.
answer is as
Yeah.
adiabatic
will
process.
be
So we can
the
log the
most
second.
second option.
Okay. So we can move on to the next question.
Next question.
Okay.
79th question, sir.
Okay. The capacitance of a parallel plate capacitor with the air as medium is 6 microfarads. So
Yeah.
we can write epsilon 0 by D is equal to 6
microfarad.
microfarads.
Yeah.
Now, with the introduction of a dielectric medium, the capacitance becomes 30 microfarads. Okay. So then the expression becomes A epsilon 0 epsilon R by D is equal to 30 microfarads. Now, the permittivity of the medium, not relative permittivity.
The
We want to find epsilon.
Yeah.
So by dividing this with this,
Yeah.
then epsilon 0 dr.
So equation 2 by 1 you can do, sir.
Yes, this is 1,
Yeah,
this is 2,
this is two.
2 by 1.
Yeah.
Then we will get epsilon R.
So
That
30
is,
by 6.
that is 5.
5 microfarad
Five.
you are getting.
Sorry, this will
I mean,
strike.
cancel B, so 5 will be.
5.
It's a constant.
Yeah, the
Epsilon
mu epsilon by epsilon 0 is equal to 5. So epsilon is equal to 5 epsilon 0. That is 5 into 8.85 10 raised to
Minus
12.
Yeah.
So its value will be
5 into 8.85 is that 5
10
into
raised to minus 12 is
Okay.
here. So it's 40 is something.
Then 46 is coming.
Yeah, and if we
The
give
power we have to make it up.
two
sir.
places.
Because 2 places are there coming 40 is actually 44.
0.44.
Yeah, 0.44.
Yeah,
So
10 raised to minus 10 big.
yeah, minus 12 is there. If you get to minus 10.
Yeah,
will come.
so minus 10
third
raised to
answer.
13.
So 2 steps you have to do only. First you have to find the epsilon r,
Yeah.
the relative permittivity.
From that
there,
epsilon.
permittivity you can get it. Okay. The same epsilon r you can put the term of k also.
K also.
The relative
Fine.
constant like
Yeah.
that. You can put it. Fine. We can move to the next question.
Next question.
Yeah. Question number 80. An electron is accelerated from rest through a potential difference of V volt. If the de Broglie wavelength of the electron is 1.227 into 10 to the minus 2 nanometer, the potential difference is from dual nature of matter.
Yeah, direct.
That equation de Broglie wavelength in terms of potential, you know.
Yeah.
Lambda is equal to 1.227
12.27 divided by root
root
V, I
V.
think.
Yeah, that means Armstrong.
Yeah.
Yeah.
Nanometer, right? Sorry,
One-
Armstrong.
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 1.227 in the nanometer.
Nanometer.
12.27 Armstrong.
Yes.
By root V. We have to find the potential difference V actually.
V.
Lambda is given there. Okay.
We want to square it.
Yeah.
I think. So,
So,
lambda is 1.227
into 10 to the minus 2.
10 raised to minus 2
Nanometer it is.
nanometer.
So into 10 to the
raised to
minus 9.
minus 9 is
Equal
equal
to,
to
12.27 into
12.27
into 10 to the minus 10.
raised to minus 10 divided by root
Root
V.
V, yeah.
Okay, square it and take it. So
Yeah.
V is equal to 12.27 into 10 raised to minus 10 square divided by this value.
So squared.
1.227
Square.
square into 10 raised to minus 2 into 10 raised to minus 9
Square will be there, sir.
square, yes, whole square.
Yeah.
Okay, so that will be equal to
Just get cancelled out.
cancel out.
So there will be here 10 raised to minus 2
Here,
minus 11.
While cutting these two, there will be 100.
Yeah, 100. There's 2 will
So
be there.
100 10 square into 10 raised to minus 10 raised to minus 20 into this becomes
Minus 20.
11 22.
Yeah.
10 raised to plus 22.
Yep.
So answer is
22 minus 20 is 2. So 10 raised to 4.
10 raised to 4 is the right answer. So,
So 10 raised to 4 volt. That's the fourth option.
Fourth option.
Fourth option we can log in.
Yeah.
Fourth option is the correct answer.
Sure.
Focus number 80.
I think it's from dual nature.
Yeah, dual nature of matter. From dual nature, we got 3 questions actually.
3 questions.
It's a small chapter actually.
Yes.
So it is got 3 questions from there.
Okay.
So actually the normal weightage is a little bit changes, slightly
Change
changed this time.
in this time.
But expected actually.
Yeah.
Compared to.
Exactly. So shall we move on to the next question?
Yeah, of course. Question number 81.
81.
A wire of length L, area of cross section A, is hanging from a fixed support The length of the wire changes to L1 when mass M is suspended from its free end. The expression for Young's modulus. It's question from mechanical properties of solids.
Yeah.
We have one question from there and one
question.
question from fluids also.
Fluids also.
So it's a direct question actually. So a wire of length L is suspended freely. Okay, one end is fixed. L1. So it's extend to L1. So you know Young's modulus basic equation we have, sir.
Yeah.
Y is equal to
This is like
Yeah,
initial length
yeah.
L and
Yeah.
final length is L1. L1.
So we have Y is equal to F into original length by A into change in length.
Yeah.
That's the actual equation.
Yes.
So here if it is hanged by mass M,
applied
we know that
force is
yeah, mg will be there. If mass is M, then mg
G
into
L divided by
A is the area of
A
A.
is given as A.
A is is given.
A into
Change in length is what?
L
Final minus initial.
1 minus L, I think.
Direct equation.
Direct equation.
That's A.
MGL
So we
divided by-
have the fourth one is the, we'll give the comparison. mgl by A into L1 minus L.
So shall we move?
Yeah, we can move to the next question. There are 82 questions. The Brewster's angle IB for an interface should be
Oh, from
polarization
wave optics.
topic, wave
Wave
optics chapter.
optics, yeah.
So that's from the third question from wave optics.
Yes, yes.
We have 3 questions from wave optics we got.
Yes, yes.
Brewster's angle IB. We know that
So-
tan IB is equal to mu.
Tan
IB is equal
IB
to
is equal to
mu. The refractive index.
Sometimes is letter is taken as P also.
P also, polarizing angle.
Yeah.
The polarization topic it's actually.
Yes. Here mu is the refractive index of the medium.
Medium.
For
denser medium, yeah.
polarization, the refractive index of medium should be greater than air.
Yeah, of course.
Okay.
Yeah.
So mu should be greater than 1.
Yeah.
So tan IB should be greater than 1.
1. So,
So,
IB will be equal to tan
IB
inverse mu.
Yes. IB is equal to
Tan inverse mu.
inverse of mu.
So, this question actually coming, what will be the range of IB?
Range
from
of IB.
where to where it can be.
Yeah.
So, different ranges are given there.
It
So,
should greater than 1.
of course.
Yeah.
So, minimum will be
Not
tan
greater or
inverse,
equal to.
tan inverse 1, that comes to 45 degrees.
45 degree. So,
So
angle
least
should
will be 45 degree.
Yeah, least will be
Not equal, above 45.
Above 45 degree. So answer should be in between 45 and 90.
Yeah. So, above 45, only one option is there. Sir.
The value 90 is also not taken.
Not taken. Because infinity will come.
Infinity.
So, possible. So, third is
Answer
answer.
is 3.
So, between 45 and 90 will be
90 will be.
the value of IB, the Brewster's angle. It's a
Yes.
basic concept actually.
Yes.
Logic ideas.
Simple concept.
Yeah. We can move to next, sir.
Oh, so I think it's from laws of motion.
Yeah.
Two bodies of mass 4 kg and 6 kg are tied to the ends of a massless string. The string passes over a pulley which is frictionless. The acceleration of the system in terms of acceleration due to gravity in terms of G is
You have to find out
simple
it.
direct equation.
So it's a
Acceleration-
vertical connected body, sir.
Yes, A is
Yeah.
equal to change in mass.
Yeah.
6 minus 4 into G, change in mass into G
Yeah.
divided by total mass.
Yeah, 6 plus 4. We
Answer
have A is equal to
2G by 10.
yeah.
That is G by 5. So answer is
M1 minus M2 by M1 plus M2 into
Into
G.
G.
Vertical connected bodies.
Yes.
So G by 2. G by 5.
G by 5. 3 is the right
Right
answer.
answer. Correct question is okay. From laws of motion that
Laws
we
of
got.
motion. I think one
question
question.
from. And there was no question from work energy chapter also,
Yeah.
sir.
There
No
is
question
no,
was
no
there.
question.
Yeah. Question number 84 we can move.
Yeah, sure.
And another direct question from Municipal measurement. Dimensions of
Stress.
stress. Actually 3 questions we got from dimensions.
Dimensions.
Units of measurement.
Units of measurement.
Chapter. Stress is force by area. Similar like pressure only.
A pressure M
this
L
another-
raised to
yeah.
minus 1.
Yeah.
T raised to minus 2.
Yeah. Direct
Pressure.
Yeah, pressure.
Same.
Yeah, force by area. Force is ml t power minus 2.
Yes,
By area is
by
ml
L
square.
square.
Cancel it, you'll get ml inverse t
raised
power
to
minus
minus
2.
2.
So stress is that question. We can move to next.
Sure.
35th. A screw gauge has least count of 0.01 millimeter and there are 50 divisions in circular scale. The pitch of the screw gauge is another direct question.
Direct question. Yeah.
Practical oriented question also.
Yeah.
We know that least count LC is equal to pitch by number of divisions.
Yeah.
Is it?
LC is equal to pitch
LC
by
is
number
equal
of
to
divisions.
Pitch divided by number of divisions.
You want to find pitch.
Yeah. So number of divisions are there.
Okay.
So pitch you have to find out actually.
Yeah.
So pitch is equal to
LC into number of divisions. So
we have
pitch is equal to
LC is 0.01 sir.
0.01
into-
millimeter. le?
Yeah, millimeter.
Yeah.
Into
Into 50.
50
Answer is 0.5 millimeter.
millimeter. Some students used to by heart the pitch actually,
Yeah.
but not here. It's 50 divisions.
50 divisions.
Normally have 100 divisions.
100 divisions.
So
Yes.
50 divisions.
Yes.
Yes.
So answer
0.5
is
millimeter.
0.5.
Good. We can go to the next question. 86th question.
The energy required to break one bond in DNA is 10 raised to minus 20 joules. This value in electron volt is
Nearly.
You want
Just
to find
unit conversion only.
Unit conversion.
That's
From
what
joule to
Electron volt. Yeah.
Simple.
Yeah. We
Divided
have
by
one electron volt
1.6
is equal to,
times
yeah.
90.
1 electron volt is equal to
1.6
into
10 raised to
10 raised to minus
minus 19 joules.
So here, joule is given, you have to convert to.
Yeah.
So we have 1 joule is equal to
1 by
1.6 into
10 raised to minus 19
electron
volt. So you want to find
10 raised to minus 20 joules you have to
20
convert.
10 raised to minus also.
So we
Multiply
have, yeah.
LHS
So,
and RHS.
yeah, 10 raised to minus 20
is equal to
yeah.
10 raised to
Minus
minus 20 divided by
1.6 into 10
raised to minus 19.
Yeah.
We can take this term the
Half, so
numerator,
become,
so that will becomes 10 raised to minus 1
1 divided by 1.6.
1.6. That is equal to 1 by 16.
Yeah.
I think. Okay.
Yeah.
So its value
1 by 16 is almost 0.06. Sir.
0.06. Yes. Answer is 0.06.
0.06.
Simple question.
So that is third answer. We can look at.
Yeah.
Conversion of the units actually from electron volt. Question number 87.
I think this question is coming under this chapter.
Dual nature we can convert electron volt concept.
Electron concept.
Or it can be included in units of measurement
Units of
also.
measurement also.
Conversion of the units from one system to another system can be done also.
It's a general
Yeah,
question.
then question we can say. 87th one is the color code of resistance is given below.
Yeah.
So from characteristic again
It's
the
very
next
simple
question. 5 questions came from characteristic.
Yes.
Yeah. Yellow, violet, brown, gold is there. You know the famous color code. B.B. Roy of
B.B. Roy
Great
of Great
Britain
Britain
has a great vibe.
Sometimes
Very good.
I'm
Yeah.
telling like black brown Roy
Ah.
of Green Britain has very grey vibe.
Okay, that's also,
Okay.
yeah, somewhat with gold, silver necklace.
Yes.
Yeah, okay. So we have yellow, violet, and
4.
brown. Yellow is
Value
4.
of 4 and white is 7.
7. Brown, is 0.
is 10 raised to
Yeah.
1.
That is
10 to the
1.
power
With that, yeah.
1 and gold is
5%.
tolerance plus or minus 5%.
5%.
So answer is 470 plus or minus 5%.
So
So option
4.
4 is the right answer.
So resistance and tolerance respectively are 470 ohm and 5%.
5%, yes.
Fine. Not to confuse that at all because everything is okay.
Yeah.
4.7 kilo ohm, that's all nothing. We
Exactly.
can move to the next question.
Oh, sure.
88th question.
Assume that light of wavelength 600 nanometer is coming from a star. The limit of resolution of telescope whose objective has a diameter of 2 meters. So we want
That's
to find
from the
limit of
optics, yeah.
resolution,
Yeah.
not
Resolving power.
resolving power.
So reciprocal of limit of resolution is resolving
Resolving
power.
power.
So directly connect.
Directly. So
That's from wave optics chapter.
wave optics, I think.
Yeah. So theta is equal to, we can write.
Theta, I think it's telescope.
Yeah, telescope for this
So
one.
answer is 1.22 lambda by d.
D.
Okay, that is equal to 1.22 into lambda is
600 nanometer
into 10 raised to
minus
minus 9
9. Yeah.
divided by diameter is
2 meters.
2 meter. Okay, so cut
300.
300. That is equal to 2 zeros becomes 7.
Yeah. Then
Now
3 into 1.22.
663.
Yeah. 3.66.
3.66 10 raised to
Minus
7.
Only one answer is
Answer is
3.66.
1 is right.
One is
answer.
option.
Yes.
So it's actually,
RP is d by 1.22 lambda.
lambda and limit of resolution will be 1.22 lambda by
d.
d. From wave optics chapter.
Yeah, I think this equation is used when the aperture is circular.
Yeah. Yeah.
Yes.
Yes, you do.
But they are not mentioned in this section. This
Yeah.
is circular or rectangular. Not
So you can use the
be
general
taken as
equation, yeah.
circular. Yes, sure.
We can move to the
Next question, sure.
89. The increase in the width of the depletion region in a PN junction diode is due to.
Simple.
Very direct question, sir.
Yeah.
Very direct question.
Yeah.
So semiconductors, we got 3 questions this time.
Three questions.
3 questions came there. So depletion region is a region between PN and junction,
PN
across the
junction,
junction.
yes.
In forward bias, the charge particles come across the junction,
Across,
so it
yeah.
decreases the width.
It decreases.
And reverse bias, it
Increases the width.
So only one
answer
answer.
is reverse bias.
Reverse bias only.
Only.
It happens. 2 is answered.
Yeah.
And the last question we go to 90th question.
The energy equivalent of 0.5 gram of a substance is. So mass energy conversion is equal to Einstein's famous equation.
I think NEET will expect some general questions.
General
So also a
question.
general question. Only.
Yeah, taken as.
Yes, we can say. Is
Point
there mentioned in nuclear chapter?
Yeah.
Yeah. C square is there. So it is 0.5 grams, sir. So we should convert to
Kilogram.
kilograms.
Okay. That is 0.5 into 10 raised to minus 3 into that is 3 square 9
Yeah.
into 10 raised to 16.
16.
That is 9 into 0.5 is 4.5.
Yeah.
4.5 into 10 raised to 16 minus 10 raised to
30.
30.
Yeah. So
By
4.10
joules.
is to 30
Answer
joules.
is, yeah.
Direct. So
Direct
option is
question.
2.
2 is the right answer.
Yeah. Very
So
simple.
I think it's very
Within few times you can do the very simple questions we got it here.
I
So
think average student
Mm.
easily can write I think
course.
42 to 42 to 45 questions, I think.
can solve it directly. Hardly 2 to 3 questions only, just 2 degree level questions came. Remaining
Yeah.
all are very direct questions.
Direct
was there.
questions.
NCERT based questions was there.
Yeah.
So if you say the hardness level, what do you say about it? The difficulty level, what do you say?
I think all are
Very few questions only very hard. you can say. Is it?
very few questions.
So if I say about 55% is average question.
yeah,
About 20 to 25%, 30, okay, 35% we can say little bit 1 degree level.
little bit. Yeah.
And 3 questions we can say about it. Out of 45, 3 questions is almost
Not top level or hot level questions.
Yeah.
I think
Less than
there is
10%
no even one question from hot level.
Yes, fine.
So all are very simple, I think. But there will be some confusions for the students.
Yeah, that's maybe that the
Yeah.
presence time, presence also.
Yeah.
At
the time
students have the mixed
they are
reactions,
also
sir. Yeah.
confused since they are studying a lot of things in high level.
Yeah.
So they may be confused at that,
That confusion,
time of
that
examination.
reaction they also express.
Yes,
Students express.
they,
Sometimes these simple questions make trap also, because
Exactly.
those who work with the complex questions throughout their career time,
Yeah.
then they'll be confused how to connect the basic theory.
basic theories. Yeah.
Sometimes they have that mixed reaction.
Yes.
So this time NEET, of course, a lot of courses can be scored easily from
Easily
600,
from-
650 plus. Is
yes. I think
Yeah.
an average student,
Mm.
I think 40 questions make it
it? Can be out of 40,
easily
actually.
from physics.
And even calculation also didn't took much time.
No.
Normally you used to take it. So
Yes.
those who took time from biology,
Yeah.
easily they can score all this.
Oh,
one.
yes.
Easily. So it was time limited also.
Yes.
It was fine. So here is the analysis of physics part from the NEET 2020 UG question paper.
Yeah.
Okay, 45 questions we analyzed. Out of these, we found that almost were average questions. Okay, and below average some questions also were there. Very
Some
direct
very-
questions was there, expressions and all. So those who done focused on theory based and numericals can score a good mark from this physics part. That's our aim. And we gave the training for our students well, and they were satisfied, almost all of them. And if you are watching this channel first time, please subscribe it and stay tuned for updations,
More updations.
and more live classes and coaching videos from this Target Learning app and Bright Learning app. This is our sister concern, and this is a part of our target institutions. Here we provide coaching for grade 9th to grade 12th, science and mathematics, and all language also we provided. And for grade 11th and 12th, ongoing batch entrance oriented coachings also we provided. You can download our app from App Store and Android Play Store also. We provide constant touch for you in Target Learning app and Bright Learning app. Stay tuned. See you next video. Thank you for watching.
Bye bye.
Bye.